All right, so let's look at some of the anatomy of the human reproductive system and how um, it's regulated and creates these gametes that can become um, eggs and sperm. So here's the female reproductive system, and you're looking at a front view. So you can see the picture over here, and you can see the view you're looking at. So women have one paired uterus and a single vagina, but they have two ovaries and two ovary oviducts, which are these tubes that connect to the ovary. So let's start with where the egg develops and follow the egg all the way through the reproductive system. So here's the ovary, and you can see how the ovary looks a little bumpy. That's a sign that the woman is reproductively fertile, that they've hit puberty. Prepubescent girls, the ovaries actually look very smooth and round without these bumps. These bumps are actually called follicles, and you can see that there's this ring here, and then inside of the follicle there's a very large cell. And these follicles are where the egg develops. So you've got a very small follicle here, a larger one, and then this one looks ready to ovulate. So throughout the cycle of a woman's menstrual cycle, those follicles develop at the beginning, get larger and more mature, and then eventually burst. They are a cyst inside of the cell. And they're called a cyst because they have a fluid-filled cell. When the follicle bursts, that's called ovulation, and that's when the egg is released into this funnel here. And so this funnel sits right on top of the ovary, kind of like a hat, and it has little cells with cilia that are directing the now ovulated egg into the oviduct. The oviduct will carry the egg all the way down here to the uterus. This usually takes a couple of days. Most of the time, if an egg is going to be fertilized, it actually happens in the oviduct by the sperm that get this far. And so by the time it's reached the uterus, it's usually fertilized if it's going to be. Once the egg reaches the uterus, if it's fertilized, it will go ahead and implant in the uterine wall and then start to develop into an embryo. If the egg reaches the uterus and it never gets fertilized within a couple of hours or days after, a couple of days after leaving the ovary, then it isn't actually going to get fertilized. It won't implant, and at the end of the menstrual cycle, the entire uterus will shed its lining and the egg out of the body. So then the uterus lining and the egg will travel through the cervix. The cervix is this tough connection between the vagina and the uterus. This opening is very narrow. It's actually narrower in women who's never had a baby. And women who have had a baby, the opening does get small again, but it never actually gets all the way back to its original size. And then eventually the egg will pass through the vagina and out of the body. Notice that the vagina is a very flexible-ish area, and it can actually increase and engorge in size and change with sexual arousal to accommodate the male penis. Here you can see the male reproductive anatomy, and this is a side view, so you can see the man here and he's standing sideways. So let's do the same thing we just did, and we'll follow, instead of the egg this time, we'll follow the sperm. So the sperm is made in the testicles, which are held in the scrotum. And in mammals, they are held in the scrotum outside of the body to help keep the testicles a couple of degrees cooler than the inside of the body. We think this is an evolutionary adaptation for warm-blooded mammals. However, not every mammal actually has a scrotum. Some large-bodied elephants actually have internal testicles. So we're not really sure why the testicles descended into the scrotum, but we know that they can't be internal, otherwise they would cause infertility in humans because the high body temperature would reduce the sperm count. So the testes right here, and these are paired, make sperm. The sperm then moves into this structure here called the epididymis. This is where the sperm matures, so it goes from immature to fully formed sperm. The sperm is not activated, it is not swimming here. The tube itself is what is propelling the sperm. We don't want to activate the sperm until they reach the vagina for the best chance of conceiving. The sperm then enters this tube. The sperm is held here in the epididymis until an ejaculation. When an ejaculation occurs, then the sperm will enter this tube called the vas deferens, where it goes all the way up over the urinary bladder into what is called the ampulla. There's a gland right here called the seminal vesicle that secretes a fluid that helps to support the sperm and it provides nutrition. The sperm then travels through what's called the prostate gland, and this is where the two sides meet. So this is the vas deferens of the left side, and then this would be from the vas deferens on the right. And they merge here in the prostate. The prostate is what secretes the milky secretion, which gives ejaculate its white milky color. And this again supports the sperm. It creates a nutritious environment for the cells. The sperm then continues to travel through what's now called the urethra. The last gland here is called the bulbourethral gland, which is paired as well. And this secretes a pH buffer. Because in males, the urethra is shared by the reproductive tract and the urinary tract. That means that ejaculate and urine travels through the same tube. So the bulbourethral gland actually helps to neutralize the acidic urine so that the urethra is a good environment for the sperm cells. It also activates the sperm. At this point, the activation would occur and the flagella on the sperm cells would start to swim. And then the sperm is expelled out of the urethra, out of the penis. Gametogenesis is the process of creating gametes. So spermatogenesis is the process of creating sperm through meiosis. In men, this actually occurs, it begins at puberty and then continues until death. So most men remain fertile their entire lives. The amount of sperm production does taper off as men get older, but it's usually still enough to impregnate a woman, all the way up into like 50s, 60s. Oogenesis is the production of eggs or ovum by the process of meiosis. And this happens in two different phases for women. The very first phase happens before birth, where you produce as many pre-egg cells called primary oocytes as you're ever going to have. And so every woman is born with the number of eggs they're going to have, and this is usually somewhere around 5 to 10 million. And this gets paused during infancy and childhood. This process then picks up again during puberty when the level of estrogen rises. Each cycle, a female only produces one single egg cell. Whereas in spermatogenesis, men produce anywhere from 2 to 4 million sperm cells per ounce of ejaculate. Females have a very complex reproductive system, which is made of a cyclical change in hormones. And this produces what's called the female reproductive cycle. And this happens in two different locations. There are events occurring in the ovary as well as in the uterus. So what's happening in the ovary is called the ovarian cycle, and what's happening in the uterus is called the menstrual cycle. So if you look at these graphs, the left side of the graph is time, which is days in the menstrual cycle. The typical female menstrual cycle is about 28 days, but a normal menstrual cycle can be anywhere from 25 to 40 days. And that's totally normal. So on day 1, we start counting the menstrual cycle with the first day of noticeable bleeding. So menstruation is when this begins. So day 1 is on the left of all of these charts. You can see that in the ovary, the follicle is very small. In the uterus, here the thickness here is the uterine lining. The uterine lining is being sloughed off and shed. All of the hormone levels are fairly low. By about day 5, the uterine lining starts to pick up, and that's because of an increase in estrogen hormones. So as this estrogen surges, it's allowing the uterine lining to become thicker. The estrogen is actually secreted from the growing follicles. So as the follicle gets larger and larger, it secretes more and more estrogen, causing this spike and the buildup in the uterus. This spike in estrogen causes another spike in a hormone called luteinizing hormone, or LH. This LH spike is what triggers ovulation. So right here in the middle, at the middle of the cycle, is called ovulation. And this is in the uterus, in the ovaries. This is where the egg breaks out of the follicle and is now going to move into the ovarian tube, the oviduct. At this point, the levels of hormones break off and lower, except for progesterone. Progesterone increases, and that's created by this corpus luteum, which is what's left of this follicle as it degenerates. If the cell becomes fertilized and implants, this corpus luteum would persist and create progesterone to maintain a pregnancy. However, in this cycle, let's say that the egg does not get fertilized and it doesn't implant. Eventually, this corpus luteum will degenerate, which will cause this progesterone level to drop. The drop in progesterone is what triggers the menstrual cycle to begin again and causes the endometrial lining, this lining of the uterus, to break off, get sloughed off, and shed, and begins bleeding once again. We can use what we know about the biology of anatomy as well as the physiology of hormones in the menstrual cycle to prevent pregnancy. And that's called contraception, and that's the deliberate prevention of pregnancy. The only type of contraception that is 100% effective is abstinence, which might be effective in younger individuals, but is not necessarily a preferred form of contraception for most couples. So one of the most effective is sterilization, and so this would be something called a tubal ligation for women, where the ovarian tubes the oviducts are knotted and clamped. And this is called a vasectomy in men. The picture shows scissors here cutting the tube. That's not always the case. This can be done so that it's reversible. And then we have other types of hormonal birth controls, like the IUD or the arm implant. There's a hormone injection, pill, patch, and vaginal ring for females. We have just, as a country, started testing hormonal birth controls on men. And one of the very first prototypes was just released and approved by the FDA. So we'll likely see in the next several years forms of birth control that men can take daily to prevent fertilization. Women, we have the IUD, which is called the intrauterine device, and this is implanted into the uterus, has to be done by a doctor. And this generally lasts 3 to 10 years, depending on the size of it. So most gynecologists won't give you one of these if you're planning on having a baby in the next, 1 to 2 years. The arm implant lasts about 3 years. And what this does is it's placed under the skin, again, by a medical professional. And it's very flexible. You can feel it, you can palpate it, but it doesn't cause discomfort. And it releases hormones for several years that help to prevent pregnancy. The hormonal birth controls work because they disrupt the regular menstrual cycle. And when the regular menstrual cycle is disrupted, it never allows for ovulation. And so that prevents the fertilization from happening. The injection has to be given every 3 months. The pill has to be taken daily. There's a patch where you change it once a week, and a vaginal ring that's inserted once a month. And all of these methods release very similar hormones, estrogen and progesterone, into the female body to help disrupt the reproductive cycle. There are also physical barriers to prevent pregnancy, one of which is called the diaphragm, and this is for females. This is inserted into the vagina before sex. It's usually filled with a spermicidal jelly. This has a 12% chance of getting pregnant, so nowhere near as efficient as the hormonal birth controls. They're also very hard to find nowadays. Most manufacturers are not making many types of diaphragms. There are 2 types of condoms: the male condom, which covers the penis; the female condom, which actually is inserted into the vagina. The cervical cap and the sponge are kind of a similar to the diaphragm, where they're inserted into the vagina before sex. They cover up the cervix, and they physically prevent sperm from getting into the uterus. Again, they're not as effective. They actually have to be left in the vagina for several hours, up to 6 hours after sex, to be effective. You can't just take it out right away, because then the sperm that are still in there can get into the uterus. Spermicide is just a gel, which is used to kill sperm. By itself, it's not very effective. It's usually used in conjunction with the cervical cap or the sponge or the diaphragm. You'll find that when you look at condoms, there are many condoms that have spermicidal lubricant added as an extra line of defense against conception. And then fertility awareness-based methods, that's called the calendar method or the rhythm method. And this is going to be where you track the female reproductive system and try to avoid having sex on the days when she might be ovulating. Another method is called the withdrawal or coitus interruptus method. And this is this is when the male withdraws the penis before ejaculation. This is not a very good effective method. Male ejaculate has semen in it before the actual ejaculation occurs. And so even a successful withdrawal can still result in pregnancy. There is emergency contraception, which is called Plan B, and those can be taken after a unsafe sex event. They should be taken right away. After about 48 hours to 72 hours, they no longer become effective. The Plan B contraceptive pill is not an abortion pill, and it will not abort a fetus that has already been fertilized and implanted. So there's no concern with that being an abortion. It only prevents pregnancy if it hasn't already occurred, which is why it has to be taken right away.